1. Good afternoon, everyone. My name is Von Austin. My group members are Jamie Singh, Trevor Tobin, Ravindra Joda, Louisiana Derup, Chrisan Bacchus, and Yugita Pudram. For the entirety of this presentation, I'll be going through with you the bioinformatic tool known as Clustal W. Now, what is Clustal W? Clustal W is basically a multi-sequencing bioinformatic tool, which is basically used to sequence protein and nucleotide, or to find the alignment between the two sequences. Some of the algorithms that are basically used in this program is firstly the progressive alignment algorithm, which is an algorithm which basically starts at regions between the sequences that has high commonality and then move to regions which has lower or less commonality between each other. Other alignment algorithms are used as a pairwise alignment algorithm, which is basically an algorithm which generates scores according to the number of mismatches or matches between the alignment. The matches will get positive values, whereas the mismatches will be given negative values. And this will be explained in more detail later on. Another algorithm that is used is the neighbor joining algorithm, which is a simple algorithm that is used to help generate a guided tree, which we'll be more familiar with it as a cladogram. Now, that will be explained here in the procedure of how the Clustal W works. Now, basically, a person will have a number of sequences or sequences they are interested, which are basically known as golems. In this situation, they have 7 golems. Now, the pairwise alignment basically give us our scores, which we can then use to calculate our distance matrix, which is the number of differences between the golem's alignment. Now, as you can see here, the loop has a much longer branch because it has more difference or less matches between the other sequences. So it is much further away. But the human and the horse sequence has much more similarity. So they have shorter branches and they are more closer together. Now, after this distance matrix is taken into consideration, the weight of the sequences are then taken into consideration, which helps to generate this rooted tree, which we are more commonly known as a cladogram. And as you can see here, the actual result shows us that this Luplu organism or the Luplu sequence is far different from the human or horse sequence, which we see here as being more common to each other. The image below basically shows this entire process being repeated throughout the 7 golems or the 7 sequences. Now, how can a person execute the Clustal W algorithm program? Sorry. Now, basically, they would have to go to the EBI website, which is shown with the URL here, where the user will then be given a dialog box where he or she can then copy and paste their sequence into the dialog box here, or they can use the choose file option, which you can see here highlighted in red, to insert their sequence. Now, it is also important to note that the name of the sequence must also be inserted with a greater than sign in front of it, and it must be in its own line. As you can see here, where my mRNA, where my name of the sequence ends in mRNA, a new line is then created where the sequence is inserted. After this, the user has inserted their sequence and begun the program. They are then presented with a number of options where the user can then alter the parameters for the pairwise alignment or the multi-sequence algorithm. As you can see here, we can assign different scores to gap openings or gap extension. All of these are various different parameters that the user can change. Additionally, as you can see in step 4, the user can have the option of being notified when an email is via email when the program is finished. Meaning when Clustal W is finished aligning the sequences, It will then send a notification to the user that the program has completed a task. When the task is complete or the sequencing is done, the user will be provided with an option to download the file or the results, as you can see here, highlighted in red. Now, if the person does not have Java into their system, they can view the results via the software GL View, which can be started with the Start GL View button, as you see highlighted here. And what this does is that it basically creates a more viewer-friendly option. Now, as you can see here, the you can clearly see or more easier see the cytosine to cytosine alignment or guanosine to guanosine alignment because it is highlighted in different colors. So it is more viewer friendly. Additionally to the results, what are also given are the length of the sequences as well as the alignment score of the various sequences. As we can see here, the 4 sequence is 700, 576 base pair long, and the number of alignment between the 4 sequence or the alignment score between the first and second sequence is a simple 86. And with that, I come to the conclusion of my presentation, and thank you for your time.